Hey, what's up? My name is Daniel Higginbotham, and I'm going to be talking to you about Donut, a single-page app framework for building your online business written in Clojure. We're going to be looking at why Clojure is a great choice for indie hackers and solo devs, and we're also going to be looking at the problems that a Donut framework aims to solve. And finally, we're going to look at a little demo of Donut in action. Okay, so to get things started, I want to talk about why Clojure is a great choice for people who are looking to build an online business. So the people I have in mind are solopreneurs, indie hackers, or even people getting into programming for the first time. And what these people have in common is that they don't have much time. They're maybe doing this in their spare time. They have limited resources, and they really want to get their product out there in front of people as quickly as possible to start validating their idea and building a real business. And so I think Clojure is a great fit for these folks, and I consider myself one of them, because it lets you focus on solving real problems, right? And what I mean by that is that you won't run into a situation with Clojure where you are spending 30 minutes out of the hour that you've set aside to work on this on your Monday night, trying to debug dependency issues or something like that, something which is totally distracting and demoralizing even. Clojure lets you focus on solving real problems. That's the main reason. Another reason why I think Clojure is a great choice for such folks, especially for beginners, is that Clojure makes so many good choices, and by learning Clojure, you are learning great habits which are going to serve you well throughout the lifetime of your career. Another reason why I'd love to see Clojure become the go-to language for this kind of work is that, first of all, a lot of us use it for that kind of work, and so it'd be great for us. But beyond that, right now, it's kind of hard to say what Clojure is the best tool for to an outsider. Of course, all of us know it's the best tool for almost anything. But to an outsider, you can compare Clojure to a language like Python, for example. And Python is known to be pretty much the best tool for data science. If you're going to do data science, you're likely going to learn Python. Especially if you are new to programming at all, you want to invest your time wisely. You want to make sure that this time you spend learning a programming language, learning a new skill is going to pay off. And with Clojure, we don't quite have a story like that, a compelling story that tells someone, a newcomer, if you learn Clojure, if you learn these tools, there is going to be a good payoff for you. So I think if we are able to tell the story that Clojure is the best tool for launching your dream, that is a really compelling reason to learn this language. Now, I think that creating this kind of clear and compelling story will benefit all of us. It'll bring fresh faces into our community, and it'll also bring fresh ideas and libraries into the ecosystem. Beyond that, it will make it easier to hire and get hired, and I think that that's pretty important for the long-term health of a programming language and its community. And as someone who's been a part of this community for a long time now, who has lots of friends here and who really admires, all the work that we all do, I really want that for us. And so that's part of why I'm creating this framework. The final reason I'm creating this framework is that I want to make it easier for anybody, including beginners, to learn these skills and to enter into this space. Doing that can be life-changing. It was for me, and I want to create that kind of opportunity for other people. Sometimes, Clojure is built as a language that's for experts by experts, but I think that that's unnecessarily limiting. When you think about the category of programming experts, that's actually a pretty narrow, homogeneous category. But the truth is, anybody can learn Clojure, anybody can learn these skills, and anybody can build an app and get their idea out there and improve their circumstances. And I think it'd be pretty awesome for us to help other people do that. Okay, now let's talk about Donut itself. I want to walk y'all through some of the high-level ideas behind it and how I've been thinking about designing it. I know the Clojure community is not always a big fan necessarily of frameworks, and for good reason. So I want to talk about how I'm trying to accomplish the goals I talked about earlier, while at the same time, not running into the same pitfalls that other frameworks into that make developers, hate frameworks with unbridled fury. Like they can so easily become footgun factories. The main idea behind Donut's design and development is actually taken from Clojure. Just as Clojure allows you to focus on solving real problems, Donut is meant to allow you to focus on solving business problems as much as possible. Take, for example, handling forms. If you've spent hours or days or however long trying to build a system to handle forms in your front end so that you can store them correctly and then send the data to the back end and handle the responses, well, I'm gonna guess that that's actually not part of your business's core value proposition. Form handling is something that needs to get done one way or another, but it's not part of the business problem that you're trying to address. So Donut is meant to handle those kinds of problems for you. I've tried to design Donut so that it can support this kind of plugin architecture without falling into the same trap that other frameworks fall into, where people feel like they're in hell and they can't escape. That is the magic that other frameworks introduce that Clojurists hate and that we want to try to avoid. So with Donut, I've taken a cue from Clojure again, where Clojure resides on top of some underlying system like the JVM or JavaScript and has a very clean and transparent interface for doing interop with that system. With Donut, the pieces that Donut introduces exist on top of widely used, well-liked and very useful libraries like Ring and Reatit and Reframe. So when you're using Donut components, they're just implementing some functionality within a system that already has a thriving ecosystem and that you can continue to use cleanly with the pieces that Donut introduces. And if there's something that you can't do with Donut, you can always fall back to the underlying system. So you're not trapped in Donut land, though that does sound kind of delightful and delicious. Now it's time for a whirlwind tour of Donut in action. That's right, it's time for the demo. And to kick things off, we're going to look at some very simple utilities. One is that in the front end, we have a reframe dispatch, debounce dispatch event. And if you haven't used debouncing before, then I highly recommend it. It will change your life. We also have a bunch of different toggles. We can toggle inclusion in a set in your global state atom, do a Boolean toggle a truthy value, and then also toggle amongst multiple values. So those are just some small utilities to make your life a little bit easier. Up we have Donut's navigation tool. So Donut gives you the ability to define front-end routes, and it also handles navigation events like link clicks and HTML5 history. With the routing, you are able to define your routes in Reatit, and so you can see here we have different paths, and for the current route we have nav.flow, and Reatit allows you to associate arbitrary data with your route. So when you go to nav.flow, what Donut does is it stores the current route, route's data within the global state atom. And then what you can do is you can use this subscription, which will give you the routed component. So if you look at this data here, you can see that a route has a components key, and from within there you can have a map, and here we have main, and this is just a vector, and within that vector is a function, and when we return that from this routed component subscription, this is a vector with a function in it, but guess what? Reagent treats that as a component, so we can just pop that down in here and it will actually render. So when we navigate around the site, that's what's happening. Donut's navigation suite also has other nifty tools that I can't get into too much. You can probably tell by the tone of my voice and the time on the clock that I am rushing to get through this, but one thing that lets you do is prevent navigation changes. And one reason why you might want to do this is to only allow or to throw up an alert or something, a confirmation box for someone if they're going to navigate away from a form and lose their changes. So here I've indicated I don't want to allow navigation changes, and if I click on these links, you can see the URL up here isn't changing, but if I toggle it back off, I can then change the URL. So it's more sophisticated than this, but I'll just give you a little taste of what's possible. One other thing that I want to share is the notion of routed entities. And that is that relies on Donut's way of storing entity data. You can look up route data, match that to the entity, like business entity data that's stored in the global state atom, and then create a subscription that dereferences that. So what this is doing is it's populating an entity in the global state atom, and now we are able to pull out a routed entity from that. So that's useful if you want to go from like a list view to a show view or something like that. Now let's look at one of the most important tools in the Donut toolkit, which is its form system. If you've worked with forms in Reagent, React, Reframe, you know that creating your forms is one of the most difficult things to do correctly. There are a lot of corner cases. There are a lot of decisions you have to make, like how do you handle events? Where do you store your data? Donut makes all those choices for you, handles wiring up all the global state atom to your input, your DOM elements correctly for you. And it also provides the events and subscriptions that you need for these interactions. There's a lot to the form system, and again, I don't have time to cover it all, but I do want to show you how to work with a humble, simple text field. Here it is, here's your text field, and if you type into it, you can see that text appears, which in itself is often an accomplishment when you're working with React and Reagent and Reframe. The way that we are able to render this component is we use this macro with form, and with form takes as an argument an identifier for your form. In this case, the identifier is this vector that has most basic form. And the next argument that it takes is going to be the component that should actually be rendered. We have this UI example component, not important. Within it, though, we have this input component. And this input component, it's actually a binding that the with form macro creates, this star input. That's not really an earmuff. I don't know what to call it. I think I'll call it an eye patch. And so what that is it's actually an anonymous function, and Reagent treats functions as components. And this anonymous function created by this with form macro closes over a lot of the data that's necessary to interact with Reframe and with the global state atom. So backing things up a little bit, this most basic form identifier tells Reframe where to store your form's data. This is going to make its way into the Clojure that this input function has. And so the input function wires up your DOM element to handle JavaScript events like onChange and onBlur, and it's going to call some reframe events. It's going to dispatch some reframe events, and those reframe events are going to include the surrounding context that's necessary for Reframe to know where to actually store your form data. Now, here's what I mean by that. If we use the Reframe 10x inspector, we can see that as we update this text field, there is this path donut form, and then here's the name of the form that we saw, and then within that there is this buffer key, and there we have this map that has an attribute name, which is form attribute name goes here, and then this hello reclosure. So we can see where this is showing up in the global state atom. Now let's talk a little bit more about how that actually happens. Looking closer at this input component, you can see the first argument to it is text. That tells that establishes what component to actually render. And then the next argument here is the name of an attribute, and that corresponds to this value that we see here in the global state atom. So as you type things in, this input component is able to combine a few different things. One, it knows where your form lives. Two, the Donut framework itself has this prefix path for form data. And then 3, it also keeps track of the attribute name that you give it and uses all of this information when it's dispatching reframe events in order to store your data in a in the correct place and in a known place. So part of Donut's value proposition is that it adds a little bit of structure so that there's consistency to how you represent different kinds of entities and where you store those entities. And by introducing that kind of consistency, it makes it possible for other components to be introduced. They can rely on that schema in order to do things like react to the values that you're storing into your form or react to your form state without having to every single time work with like your own bespoke organization system. And that actually simplifies the process of creating reusable components. To expand on that a little bit, if you know that every form is going to have the same representation, meaning it's going to be a map with a buffer key for holding the current values of your inputs. And so like you have attribute 1 here, some value. It's going to have other keys like UI state is one of them, and that could be submitting. UI state, I'm not happy with that name, but whatever. We're going to keep moving here. So every form has the same representation that allows you, that handles the vast majority of cases for like what you would use a form for. And also, if every form has the same addressing schema within the global state atom, which I think of as kind of like a file system, and that's going to be donut, forms, and then form name, and then from there you're going to have buffer or UI state or whatever. That allows components to be designed to work with the system in a way that ends up being a little bit simpler because they don't have to be as configured to work with your own particular way of organizing your data. So that makes it possible to create something like a submitting indicator where you can just give the indicator component the name of your form, and it knows where to look in the global state atom to get the state it needs to determine whether or not it needs to display itself. So if I hit submit here, the global state atom is going to be updated, and that component's going to know where to look in order to get the value to determine whether or not it should show itself. I want to give you a peek at how Donut handles input validation. One of the ways that it can handle input validation is by keeping track of the input events that your input has received and only displaying validation, which is actually just one particular form of feedback, but only displaying that feedback if the input event has received certain events. So for example, if you are displaying a username field for the first time, you don't want to yell at the person immediately that they need to fill it out if they haven't even touched it yet. What we're doing here with this zip code is we're saying, don't display a validation error until it receives a blur. So when we blur out of here, you can see it says required. If I start typing into it, now that it's already received the blur event, it's going to keep updating you with the current feedback until you type in 5 characters. And it doesn't have more sophisticated validation than that, but Donut's form handling is meant to provide a really nice user experience out of the box, and it's something that you don't have to worry about. Something that's really cool about the Donut form system is that you can use it with any React component, including, for example, a Markdown editor. So what's going on here is we are extending the input multi-method, and we are using this simple MDE React component, and this multi-method takes as its arguments the data that you need to participate in the Donut form system. That way, when you call, when you're actually defining your form, you can just say input, and you can say, I want to use a simple MDE, and it's going to render that for you, and everything's just going to work. All right, we're in the home stretch here, and I want to show you a little bit of the experimentation I've been doing with trying to create a plugin system. So I don't think it's 100% there, but what is there, I think is kind of cool. So Donut, I'll say it again, relies on this idea that if you introduce a little bit of structure, it actually unlocks possibilities in terms of composition and modularity. some of the structure that Donut provides is how you represent your system, and then also where you place the definitions of your system components. What I actually mean by representing your system is covered in a different talk or the README of the donut.system library. There's also a London Clojurians talk where I go through this, but basically you can define system components using a map, and these component definitions will include things like your endpoint routes for your backend system. Now, since we are representing your system in a known way with a known structure, and there are components that some of these components have known locations, it becomes possible for libraries to leverage that information to create plugins. Now, here's how that works out for you. On the right-hand side, you can see that I've been working on this dev tool called the Donut Bakery, and this is meant to be a Donut plugin where you can have your base Donut single page app and inject this plugin into that system. And what that'll do is it will add its own endpoint routes, its own API endpoint routes into your base system. And it also provides a front end that you can use. And the purpose of that front end is to aid you in your single page app development by providing useful views on data that can often be cumbersome to navigate. That includes actually the endpoint routes themselves, and there's also a kind of schema browser here with the database page. The way you add this plugin is by calling this inject plugin function. And what this does is you give it a system definition and it updates that system definition, because again, we know how system definitions are structured and we have some conventions for where certain components within that system are going to be located. We know where the routes are going to be located, and so we can inject the bakery's endpoint routes into that system. And if we look at those endpoint routes, you can see this also, again, this uses reatit, and from there, we can see this handler. What it does is well, you can't actually see it in this code, but it relies on the fact that your system is defined as data. It's able to take that data and return it in response to an API request, and then that's how you get this view here of your endpoint routes within your browser. In case it's not clear, the bakery is actually itself a single page application written with Donut, and it is being injected into a base application to extend that base application. And so there's actually something about creating a dev tool this way, which it feels nice to me. It feels like very Lispy, and it's also exciting to me because the prospect for developers, for beginners even, is that as you learn how to use this framework, you enable yourself to create tools to enhance your own workflow in a way that's just like, that's how Emacs works, and that's how, like, what we're used to as Lisp developers, but extended to full-on single-page app development. I don't know. I'm excited about it, and hopefully, I'm not sure exactly how it's going to play out, but in the meantime, I think it's a good way of proving out this idea that Donut can provide a plugin-friendly architecture. All right, I got about 2 minutes left here, and I feel like I'm really trying to replicate the actual, like, the in-person conference experience of, first of all, doing things last minute, and then also almost going over time, like on stage and getting shooed off. So I'm going to shoot myself off here. Thank you very much for watching this talk. I'm looking forward to. I'm hoping to talk with y'all in the session after this with Kira. I also want to say, there's already been a lot of work in this space. I haven't had time to acknowledge a lot of the work that has inspired me. Definitely Integrant, and there's also useful tools already out there. The work of Dmitry Sotnikov, and then also the BIF framework out there, which is a recent addition that looks to be very promising. I hope that I can contribute something meaningful to our community. I think that Clojure as a language is so good, and it makes me almost angry that it hasn't reached what I think is its potential in terms of mind share, and but then also in terms of like ease of access and empowering people to build the applications that they want to build, because it is such a great investment and great long-term choice. And so whether or not I succeed with Donut, it's been a fun technical journey, but I do hope that even if the form it's in now isn't adequate, that together as a community we'll continue iterating on these ideas and figuring out how to provide tools and even, yes, a framework that will help beginners, newcomers, people without experience build something useful and make it easy for them to do so. Get it so that they can get their idea out there with minimal effort, get big wins and make something that changes their lives and maybe even other people's lives too. Thank you very much.